Okay, so we're gonna charge the Roadrunner Pro
Oh, shoot.
battery. What?
I totally forgot something.
You did?
It's over now, but I have reserved CD situation and the rest of it keeping in.
Oh.
I don't know.
Oh wow. Okay.
I gave it $4 to go pick up random food from
Oh, I didn't know they had it out here too.
Yeah, it's
Yeah, okay, it's 66.5 volts, which is good. Turn the current back down. Let me actually go up again. Make sure it's okay. 66.5. We'll turn the current down. Okay, so I'm gonna try leaving the voltage, leaving the current on very low though. I shouldn't do this, but I'm going to. I'm gonna try to get it to not spark when I plug it in. Because everyone was saying that, well, a lot of people say they turn the current all the way down. So I turned it just enough so that it's showing voltage. So that could be a couple amps, right? I really hope it doesn't do a big spark right now. That's what I'm trying to avoid. Oh, this is my first time using this plug, so I really hope it doesn't explode right now. I tested the polarity on the plug. I didn't test it on the...
So our plan, if something goes wrong, is you're grabbing it or
throwing it outside.
Which outside? That outside and the pool?
Yeah. I should have tested this more. I didn't test this plug yet. I tested it with the meter, but not...
As long as we're, I think, right next to it and you're willing to grab it if it's...
Okay.
I guess if you couldn't grab it, you take this blanket and you'd wrap it in the blanket and carry it in the blanket, which would be counterintuitive.
Okay, what's happening right now? It's not plugging in. It's not going in. Maybe it's just hard to push in there. Yeah.
Can I hold the camera while you
I think I got it. Oh, it's just really hard to plug in.
You had that plug on that. You're sure that's that type of plug?
Yeah, it went in.
Okay.
It's really tight. Whew, it went in. Okay. Oh, and it didn't spark. It didn't spark.
Perfect.
And look. I'm gonna do that. Thank you. In fact, I'll do it right now. Top is this side. Well, it's trying to write a T there. Okay, so what I did to make it not spark when I plug it in is I turned the amps up until the voltage showed when it wasn't plugged into the battery. As soon as the voltage showed, like it went up, because it'll go to zero, like the voltage will go to zero if the amps are turned all the way down. So first thing, I set the voltage with the amps on, not plugged in. It was at 66.5 volts. Then I turned the amps to zero. I connected the plug on that side. Then I put the amps up just enough to make this show a voltage on top. And then I plugged it in, but it's still low enough amperage that it's not showing anything going to the battery. Now we'll turn that up. Okay, so my thoughts are, and I'm making assumptions again today. I was told, my research and study indicate that these are the best LG battery cells you can get. The assumption I'm making is that these are the best, not just the best LG cells, but the highest charge rate capacity cells. So I would really be happy if this was a graphene battery, and I do hope that Voro Motors gives us the option of buying graphene, just paying the difference and getting a graphene battery, similar to how Rumble Motors offers. A Rumble Motors gives us the choice, if you buy an electric bike from them, to buy graphene batteries. Graphene batteries can charge at 120 amps and charge in less than 30 minutes. Have a 20 to 30,000 discharge cycle life compared to lithium, which is like approximately 1,000 discharge cycles, where you start to lose capacity, right? So the batteries will pay for themselves easily, the graphene batteries, right? Because it lasts so much longer and no fire hazard. and the materials are readily available, abundantly available, graphene. Okay, so I'm going to keep talking about graphene because it's time. We just have to ask for it, and I really hope manufacturers can start offering us that. Okay, we're at 54 watts just to run the charger. Right now we're charging the battery that came with the Roadrunner Pro. Let's go ahead and charge this up. I'm going to go up in the current. Oh, so if my calculations are correct, this battery should be able to handle a 20 amp charge. I made a thicker wire for it, but I do not know how thick the wires are from the plug to the battery, like to the BMS and to the battery cells. So let's see what happens. Let's go ahead and turn this up. Right now it's at 1.2 amps, 4 amps. I think the charger that came with this battery is a 3.5 amp charger, if I recall correctly. And Voro Motors sells a 10 amp charger where you can adjust the current, which is really nice. I'm so happy to see that. And Voro Motors offered that immediately, like right away, which is really, really great. Congratulations to Voro Motors for giving people the choice to stay with them and buy variable current, variable amperage chargers. So let's go to 10. We'll start with 10 amps. Okay, we're at 10.2 amps. And I don't think the battery has any kind of display on it. I don't see a display showing me how charged or discharged the battery is. There is this is 12 gauge wire, by the way, that I added. This shows us the cells that are in here. 60 volt LG battery. Here's some information. I want to go to 20 amps and just see if the BMS can handle that on the charger. See if anything gets hot. If something goes wrong, I'll be throwing the battery outside. But the BMS should shut this charge down if the cells are getting to temperatures that are not acceptable, that are beyond the parameters of the battery's abilities. So I'm going to go to 20 and see if it'll let me go to 20. Okay, we're at 20 amps. 20.2 amps going in. The plug is doing very well. I do not know how the plug, on the other side of this plug, to the BMS, battery management system, and to the cells is doing. I do not know that. So that could smoke, that could catch on fire, or it could be perfectly okay. I really hope they use thick wires in there. And if they didn't, I hope they start doing that right away. Because some of us are going to charge the battery at their maximum we're at 1,450 watts. We're at 1,400 watts, Cameron, going in.
1,400 watts.
Yeah, that's 20 amps.
So that's what 20 amps is?
Yeah. On this at 62 volts.
What's the equation? How do you?
Amps times volts equals watts, and that's watt hours. That's watts per hour. Divide by 60, I think, to get your watt seconds or joules.
Okay.
So I replaced this. I had used the charger that came with the scooter. It was a 3.5 amp charger, and yeah, this is the absolute best LG cells that I could find on Google when I did a Google search. If these are the best cells, they can take a 3.4 that I could see, based on what I could see, they can take a 3.4 amp per cell charge in current. And
Nothing feels hot.
yeah, everything's doing good. Now, if I was using a G batteries charger, which also monitors the temperatures of the battery cells, we could be charging this in 5 minutes. But I don't see us having access to that technology. But guess what we do have access to? We have access to graphene right now. Graphene is ready. It's been ready for a long time. It's just waiting for us to ask for it. Ask for graphene. And manufacturers, I'm asking you, to please bring this technology to us. It's ready, and it costs a little bit more up front, but it's going to save money in the long run because there's a couple reasons. One reason is because the cycle life is so much greater on graphene compared to lithium. So lithium, about 1,000 cycles, and we start to lose capacity, right, of the battery. For graphene, to lose comparable cycle life or capacity, or both, it's 20,000 to 30,000 cycles, charge and discharge. That's a significant difference. And then the graphene is abundantly available, and it also no fires. It's not going to have the fire danger that lithium has. See, Cameron and I had to talk about if this battery catches on fire, and that's still a possibility because we're doing an experiment right now, right? We're charging a Roadrunner Pro at 20 amps. I've never seen a Roadrunner Pro charge at 20 amps, ever in the world. Have you, Cam?
I don't think I've even seen a Roadrunner Pro charged, but how long do you expect it to take to charge at that rate?
Well, this is a 1,800 watt hour, if I recall correctly, 1,800 watt hour battery. So we're putting 1,484 watts in there right now, which is watt hours, right? So this would take about an hour and I would say 10 to 15 minutes to charge. Some of that will be lost in heat. And again, if this was graphene, instead of wasting energy to heat, instead of wasting watts to heat, more of the energy would be going into the cells right away. They charge very, very fast. Study Rumble Motors, R-U-M-B-L-E, Rumble Motors. And they also sell batteries separately, if I understand correctly. You can buy just the battery from them. You have to give them the measurements you need, a drawing of the battery, and also what kind of battery management system you need. And Rumble Motors is doing it. And any company can do this. They have to just go for it. You have to just go for it, right? Just step into the future today. Just like everybody's already doing that. We're already creating the future every single day. We're delivering it and making it every day. So, but right now we're doing a test on charging this lithium battery at 20 amps. And so far, as Cameron is a witness to, room temperature, Cam, not even getting warm.
Perfect.
I feel no warmth there at all. Not even warm. So, thank you, Voro Motors, for putting the best cells, the best LG cells in the Roadrunner Pro. Voro Motors is very interested in quality, and I would really like to see that Voro Motors be a leader in graphene batteries. Voro Motors can lead the entire industry with graphene. Graphene matches in every way Voro Motors' approach to micromobility, which is they want the most reliable scooters, the highest quality, and they want complete control of quality control, right? And complete control of quality customer service, which Voro Motors are masters of that. And there's a lot of great customer service in micromobility. Voro Motors, Mini Motors USA, and I've experienced good customer service with many micromobility companies. But right now I'm working closely with Voro Motors and also with Mini Motors USA. You can't go wrong with either company. And I would really like to see both companies and more companies, not just Rumble Motors, but many companies, or all companies if possible. And I know it is possible. All impossible things are possible, right? We just have to do it. Graphene. Okay? Graphene, this thing would already be half charged right now. Halfway charged, imagine that. Our only limits would be how much power we can get from the wall. So these chargers can also connect to electric vehicle charging stations. And I'll show you the adapter that allows that. Very commonly used is what's called a level 2 electric vehicle charging station. And Alien Ride's website sells this adapter, and it comes with a sticker, that this plugs right into a level 2 electric vehicle charging station right there. And when you plug it in, the nice thing about this is if there's power, this little LED light right here will come on. So I learned that later. I didn't know it had that at first, and I realized it later because sometimes electric vehicle charging stations are not functioning. That's very common, and it often will take a long time for those to get fixed. So we have to call it in right away when those are not working. Make sure you make all the phone calls, and just call every day if you have to. You know, those things need to be fixed. There's a shortage of electric vehicle charging stations, and that's another reason we need graphene, is because having micromobility in electric vehicles, graphene can work for electric vehicles as well. Manufacturers, Tesla, can use graphene, can make that happen too. Tesla can make graphene happen. I know Elon Musk was talking about this about a year ago and said it would take about a year to do this. Now, there's so many battery chemistries and different kinds of batteries being talked about, but graphene is ready. I mean, we can transition to graphene now, and then if things improve beyond that, if things improve in terms of the availability and accessibility of graphene, the process of making the batteries, the cycle life, the no fire hazard, if the battery can match all these things, then maybe at some point in time it could be transitioned to that other battery. But graphene is perfect. And maybe I shouldn't use that word, but I'm going to use it because it's perfect compared to what we're using. We could say it's a perfect move into graphene, right? To commit to that and make that happen. So this is an electric vehicle charging station plug, which allows, as you'll see here, this is called a 5-15. And this style of plug, if I understand correctly, and look how it looks like the plug on the wall. See that? It has this one here and these two, and look, same thing there. That's two of these, right? So this is where the Roger charger plugs into, and then this side plugs into the electric vehicle charging station plug, which is the level 2 charging station, which gives a lot of power. Now, those charging stations can have different power amounts as well. Some have more than others, but all of them have a lot of power. And if we're using graphene, it's going to let us use the maximum power that those stations can put out, I think, right? Because those, or at least a lot more of the power. So let's see how we're doing. We're still at 20 amps. Let's check everything. Okay, charger feels good. And by the way, this charger's not hot right now, it's just warm. But this stays cool actually when it's on 220 volt. So 220 volt, it likes it even more. This is 110 volt here. We're at 110 to 120 volts approximately. Let's see how many, what we're at here power-wise. So we're at 1,525 watts. And I'm gonna fill the battery. Okay, this part of the plug is feeling warm right here. And I don't know if that's because of the other side of this. I don't know. I want to open this up. Cameron, do we have tools?
I don't have any tools today except what's on my pocket knife.
I would like to, not when it's charging, I would want to turn the charger off, but I'd like to take this top off and keep an eye on the wires in there. So what I'm going to do is, because I'm feeling warmth here, not hot, I can hold it easily, it's just warm. But because it's warm, I'm going to go ahead and turn this power down. We're already at 64 volts, by the way. We're going up fast. I'm going to turn the amps down, because there's no hurry to do this. I just wanted to see if it would... I'll bring it down to 10 amps. Since Voro Motors sells a 10 amp charger, which is a variable current, variable amperage charger, those are the same thing, current, amperage. Resistance, right? We're talking about resistance. I'm going to lower it to that power and let this cool off a little bit. It should be able to handle that. I will open that up to make sure I know the wires did not start melting on the other side of this plug. The fact that this is warm, I don't think that's coming from this side of the plug. It could be the other side that's getting hot and making this and transferring the heat. This becomes a heat sink, and something could be hot inside there. And I don't want to melt anything or damage anything. But if the cells can handle 20 amps, and the wires in there or something inside here is getting hot, that means that it needs to be stronger. It needs a thicker gauge wire, maybe a better kind of plug that can handle more current. It may need a higher current plug here. I don't know what the limits of this kind of plug are. So that may be needed as well. But the BMS, the battery management system, was permitting 20 amps, which is very good. I'm happy to see that. The Dualtron Thunder 2 can handle, the BMS in that scooter can handle 56 amps. That made me very happy to learn that. I love over-engineering. And if all of you scooter manufacturers out there, all of you micro-mobility and auto industry, the entire electric vehicle auto industry, including new companies, and there's a lot of room for new companies right now. You want to start an electric vehicle auto company, go for it. Use graphene batteries. Including the existing companies, use graphene batteries. Toyota, Tesla, all the big companies, right? Honda, everyone that's doing it as well. Graphene lets us charge quick, has great cycle life, it's safe, right? How many people talk about, oh yeah, electric vehicle caught on fire in the garage, or it caught on fire but no one got hurt, right? And it's great that people aren't getting hurt. That's wonderful. But look what this is costing insurance companies. And look at the risk of life. Why risk life when it's not necessary? Graphene is a safer technology. Now, I know everybody wants to make their own battery, you know, like reinvent the wheel, right? If graphene's here and it's safer and it's more available and it's better in every way, right? Every way that matters most. It feels highly irresponsible to not make that transition. And to say, oh, but we're developing 10 other batteries right now and they all look promising. That's wonderful, but at least get us into graphene now. Of course, people are always going to be inventing and reinventing the wheel, right? But a good wheel, a really good wheel, if we use that analogy, that metaphor, right, is the graphene battery. We're still using lithium. Okay, waiting an hour to charge the scooter is not necessary. We need to have the choice, because it's available, right? The technology is available, readily available, to faster charge. And I want to thank, special thanks to Roger for selling these Roger chargers. Thank you, Roger. That's really great. And we're ready for graphene. Let's do graphene, and then what? And then can Roger make a charger that can allow us to charge at 120 amps, right? So long as we have the power available to the charger, right? Imagine a Roger charger that's charging graphene batteries at 120 amps. How great would that be? And look how small these chargers are. This is not a really big charger. Look at this. Look at my finger right here. See the knuckle right here? That's how tall that is. I don't know what the measurement is, but it's not real tall, see? And then the length, look at the length. This is one hand length. So it's like 1.5 hands of my hand, and then less than a hand length this way. I mean, this is not a really big, see this? This charges, I can charge my Dualtron Thunder 2 and my Dualtron Storm Limited at 25 amps. This charger maxes out at 25 amps on those scooters. Well, the Dualtron Thunder 2 the maximum charge I'm charging is at 27 amps. And then the Dualtron Storm Limited is maximum at, I think it's 30.6 amps. But that charger only goes up to 25 amps at 94 volts. So, but I should be able to charge no, I think at 25 amps was the limit on the Dualtron Thunder 2 as well. And I don't know, I think it's the charger limitation, right? Because I know that the BMS can handle it. But it was going to zero. The charger was going to zero when I would try to turn it up past 25 amps. So, but we were able to do 20 amps on this one. But as I said, the plug became a little bit warm. So it's still a little warm, but it's not hot. So I don't see any smoke or anything. I'll open that up and take a look at it. If I have to change this plug to a different kind of plug, I'll do that. But my recommendation to the company that makes the scooter, Boral Motors, is to give us the ability to charge at a higher currents, right? If the battery cells can handle 20 amps, if that's their rating, if they are 3.4 amp per cell in the configuration of the series in parallel, allow for 20 amp charging if my calculations were correct, and if those are the 3.4 amps per cell LG cells, which is the maximum charge current that I found, the highest quality cell I could find on Google, just looking, researching it briefly. I'm sure that if you keep looking, we're always going to find more powerful cells, but that would provide an allowance of 20 amps on that battery. So, but let's see a transition. Let's make the transition happen with the graphene. Let's do that. I think it's time. It's actually way past time, but it's never too late to do something that's really, really good, right? Because we're always looking for the better battery, and graphene is a better battery. Okay, everyone, signing off, and we'll see you in the next video. Bye.